Nikki, you're muted.
Yeah, I'm sorry. Okay, good morning, everyone. And we officially start.
Right. Welcome. I would like to welcome all of you to this stakeholder workshop of the eMERGE project. I am Jaakko Kukkonen, and I will be chairing this event with Professor Erik Ytreberg. And I'm especially happy that we have these visiting lecturers, Valerie Chatterley and Liudmila Osipova, with us. And I will now give the floor to Dr. Androniki Marakido, who is the project manager of the project. And she will brief you on some practical arrangements regarding the WebEx system. So please go ahead.
Thank you very much, Jaakko. Good morning, everyone. Good morning, everyone, and welcome to our stakeholders workshop. My name is Androniki Marakido, and I'm a postdoctoral researcher at the Finnish Meteorological Institute. Today, I will be serving as the main host for the workshop, together with Professors Kukkonen and Ytreberg. Before we begin with our workshop, I will give you a brief presentation on the features that you can use as attendees to make your participation easier. So basically, this is the webpage of WebEx events that you're looking at right now. On the bottom right corner, you can see two tabs. If you click on Participants tab, then you will be able to see the total number of participants, including the panelists, their names, but you will be able to see only your name in the attendees list. You will not be able to see other attendees' names, but you will be able to see the total number of the attendees. During the whole workshop and after each presentation, you will be able to send us any questions that you have using this tab, chat tab. You click on it and you will send all the questions addressed to me, and based on the questions, I will forward them either to the chairman or the panelists to answer. If it's something that I can answer, I will directly answer to you. At this point also, I would like to let you know that after each presentation, first we will begin with some polls that last for a couple of minutes. More information on the polls will be given later by at the same time also, go ahead and send any questions that you have. In addition, on the bottom at the right side, you can also see two icons. We urge you and we highly recommend you to use the raise hand icon if you have any questions during the general discussion, which takes place 15 minutes before the official end of the workshop. Then we will unmute you and we can discuss the questions. And if we have extra time, we might also discuss in detail the results of our polls. Next to this icon, there's also this feedback icon. You can use it if you think a presenter talks too fast, too slow, if you agree or disagree. Last but not least, at the end of the workshop and when you leave, a pop-up window will appear in your browser similar to the one you're looking at right now. This is a post-survey event, and we would appreciate if you could spend a couple of seconds to provide us with your feedback. This is very important to us. Thank you for your attention and enjoy our workshop. You can also visit eMERGE website. And now I will give the floor to Angelos.
Hello, good morning from my side as well. Nikki, yes, thank you. My name is Angelos Toris, and I am a naval architect and working as a researcher at Maritime, a research organization based in Cyprus. I will guide you through the survey, which will run during this workshop. Your views, of course, are of high importance to us, since we will be able to validate our desktop research results. The survey is mainly targeting ship owning and ship operating representatives. The survey will be split in 4 parts during the Q&A sessions, as Nikki said, after the end of each presentation. In case you're viewing the workshop in full screen, the panel will appear automatically in the middle of the screen. In case you're viewing the workshop in maximized format, the panel will appear automatically at the right-hand side of your screen. Of course, you can close the panel by clicking on the close symbol here, and you can open the survey by clicking on the 3 vertical dots at the bottom right-hand side, and then by clicking on the poll. Since the survey feature is not activated yet, you will not be able to see the poll feature right now. You will have 10 minutes to answer 3 to 4 short, close-ended questions. In case you will not click and submit your results, and automatically a message will appear after the termination of the survey that will ask you if you would like to submit your request. And enjoy the workshop. And I will now pass the floor to Erik so that we can begin. Thank you for your time.
Thank you very much. So good morning, everybody. My name is Erik Ytreberg. I'm from IVL, Swedish Environmental Research Institute, and I work a lot in eMERGE. And I will share the first part of this session. And the first presentation we have is by the coordinator of eMERGE, Professor Jaakko Kukkonen. Jaakko Kukkonen is a research professor at FMI since 2005, and he is also professor in physics at University of Helsinki since 1992. And he specializes in research on atmospheric physics and chemistry, especially development of mathematical modeling. And he has also been the head of the air quality research department at FMI, and also deputy director for FMI for a number of years. And today he will give an overview of the eMERGE project, work plan, achievements up to date, and perspectives for the future. So please, Jaakko.
Thank you, Erik. Can you see my presentation?
Yes, we can.
Okay, very good. Right, so I will present an overview of the project, work plan, achievements, and some perspectives for the future. This is a 4-year project, started about 1 year ago, and we have 18 partners from 10 European countries. So it's a fairly extensive project, and these partners represent both marine and atmospheric expertise. And we have also been selected to be a flagship project by EU, which means that we are supporting EU strategy in an important manner. The overarching aims of eMERGE are to comprehensively evaluate the effects of potential emission reduction solutions for shipping and develop better strategies and measures. So these are fairly practical aims that can be used for policy. As this is a stakeholder workshop, I would like to summarize what kind of collaboration we would like to have with our stakeholders. So first, we would like to encourage you to join the eMERGE information network at the web page. The address is given here, and you can then contribute to shaping the research priorities. For instance, how we will select the scenarios for the future. And you will also be the first to learn about the latest beyond the state-of-the-art results before your competing companies. And you might wish to review and comment some key deliverables. We would like to include your expertise and know-how in writing these. And there might also be concrete collaboration on the collection of scrubber samples on board the ships of some of our stakeholders. and maybe even use data measured by our stakeholders. And in the latter stages of the project, we will also develop a user-friendly assessment tool for the stakeholders. And we can also listen to your views in making the policy recommendations, because we wish to have the practical experience included before making such recommendations. The case studies are central for the project. We have selected 5 ecologically vulnerable regions around Europe, and there's also one onboard case study. And the measurements, we will conduct measurements on the functioning of scrubbers, the state of the environment, bioaccumulation, and marine ecology within these case studies. So practically all experimental work is within the case studies. And then this information will be extended by modeling on European scale. There has been already substantial progress on the experimental work, a lot of planning, collection of background information. Actually, this COVID crisis has given us somewhat more time to prepare for the experiments, which is good. And we will collect samples from scrubber water and from the environment. And we are negotiating with a few shipping companies at the moment for doing the sampling on board their ships. And of course, we would like to do the sampling ourselves, but it might be also possible to allow the vessel crew to do the sampling. There's also a scrubber laboratory for this work. In modeling, we will study a couple of recent years and then scenarios for some future years. And there's a setup of atmospheric and water models. There's been a lot of model development and interfacing of the models. We would like to have a chain of models representing the whole chain of impacts, from emissions to impacts. And then there will be impact assessments with the YASA gains model and some other data and models. And on the right-hand side, you will see some predictions from the steam shipping emissions model. And so we already have a capability to provide for accurate emissions from scrubber water to the seas and emissions to the air. So there's already a working capability for this. And this slide just illustrates that it's also a global capability. We can have predictions for various categories of ships like this one, or even for individual ships. For modeling of the water phase, we will use these steam emissions, and then this a central model will be open drift by the Norwegian Meteorological Institute. And we will also use data from, for instance, Copernicus Marine Service, and develop a chemistry model for open drift. And finally, we will get distributions of pollutants in Europe, like on the map on the right-hand side, and those will feed into the gains model. And let's see if we can see the animation. There's an animation with the open drift model that just illustrates what kind of information we could get. Finally, this would be done, of course, for European scale and including water chemistry. In this case, it's just a smaller domain. This color code indicates the height in this figure, height from the sea surface. For atmospheric modeling, there will be European scale modeling on a resolution of 5 kilometers for concentrations and deposition. Then for case study regions, we will have a higher resolution 1 kilometer modeling, and we will use 2 European scale models for this purpose. And finally, we should have distributions of concentration like the one example on the right-hand side for the case studies. This is just an illustration of the CLAM model by which you can compute global concentration distributions, and then you can have higher resolution zooms for instance, for Europe, and for instance, for the case study regions. Higher resolution. For impact assessment, we will use the GAINS model by YASA, and this is a way of integrating the previous activities. So we'll use, for instance, scenarios for using scrubbers or not using scrubbers or a small fraction of scrubbers, maybe some other abatement methods. Then we will compute activities for shipping, pollution concentrations in water and air, and then you can evaluate the impacts on human health, climate, and environment. And all of this we would like to include to the GAINS model. Part of this is already in GAINS. Sorry. And finally, we would like to find out which emission controls are the best for the marine environment. So the questions that we will address are, for instance, how much the impacts can be reduced, what are the least cost shipping emission controls, will land-based measures be actually be more cost effective? So, and we will consider water quality, air quality, control costs, climatic impacts, and impacts on the flora and fauna of the seas. So this is a very ambitious, of course, and very extensive activity. For health impact assessment, we have 2 approaches. We will analyze health impacts using predictions of concentrations and health data. This right-hand side figure shows some concentrations computed with the CLAM model for the so-called MCC, multi-country, multi-city network. So we will use also a global assessment of health. But of course, we will focus on Europe. And then for the GAINS model, we will use another kind of health impact assessment, including also the costs and cost efficiency. So some perspectives on the expected results for the future. We will arrive with comprehensive information, much more comprehensive than in previous studies, on the environmental impacts of shipping. And especially we hope to get some measured data on the impacts of scrubbers on marine environments and via the atmosphere, and new harmonized knowledge on both water and air pollution, both on a European scale and within the case study regions. And finally, we will evaluate the cost effectiveness of the available methods and recommend policy actions for EU and globally. So conclusions, we expect to improve substantially the scientific expertise and knowledge on these vulnerable areas in the whole of Europe. And we expect to provide new knowledge and policy guidance on the impacts of scrubbers. I feel that we have had very nice progress up to date, despite some delays in experimental work caused by the COVID measures. And I hope that we will have intensive collaboration with the stakeholders, because that's really crucial for the success of the project. Thank you.
Thank you very much, Jaakko, for a nice overview of the project. We have some time now for some questions from the audience or the other participants, and you can write them in the chat, and Nikki will forward them to me.
Yes, and now we will first start with our polls. Take a few minutes to. Yeah. I'm sorry.
So any questions or comments?
Will you do the poll now first, Nikki?
Yes.
Okay,
now
here
the
it comes.
polls are open.
Yeah. Okay. Good. While you answer that, I think we had a question. There's a question, Jaakko, who are the partners that run the atmospheric dispersion models on the local scale?
There are several partners running local scale models. For instance, University of Hertfordshire will run the OSCAR system. I showed one example of the OSCAR system application for London in the presentation. And then, for instance, for the Athens region, our colleagues at Aristotle University will do some modeling.
Okay.
So practically all the case studies have some local scale modeling.
Yeah, that question was,
also,
by the way, from Giovanni Bonafé. Sorry, Nikki. Yeah.
Yes, and also Mikko Heikkala his question is, what is the timeline of eMERGE?
Timeline is 4 years. So we have 3 years to go, and we have done the project for 1 year.
Paul Woodlad asks, you mentioned you would get data from 100,000 ships, 300,000 ships. Are that many in the world?
Yes, this data is the AIS system, automatic identification system of ships, that is used by the STEAM model. So this global figure referred to computations using the STEAM model, where we have used the AIS information. And it's really a huge data set of information, which is then used as input for the STEAM model. And finally, the model will produce these distributions of emissions globally. So this referred to the AIS data.
If we have some time, there's also one question by Paul Altenda. What business as usual scenario do you assume?
What businesses use the scenario? We are planning the scenarios. They are not fixed yet. So we still have to do more work on defining the scenarios. And that was one question I had for stakeholders, that if you would like to have some use on what kind of scenarios we would need to address, that would be very valuable to know. And we are now in the process of defining scenarios.
Jaakko, there's also a question from Octavio Marin in Germany. He asked what other abatement systems we will look at in addition to scrubbers.
Yeah, well, there are lots of systems, of course, and one interesting possibility is the use of LNG ships, and that has increased a lot during recent years. So we will, for instance, study the methane slip from LNG ships, but of course there are various after treatment devices, and I wouldn't like to go too much to detail here, but there are several systems, and we would like to consider all all of the emission reduction systems and after treatment systems, and also alternative fuels, like for instance LNG.
Good. And there's another question from Octavio. He asks if we plan to use the MUMPEC BW model.
Yes, that also will be used. I apologize if that was not mentioned, because the presentation is so brief overview. But MUMPEC model will be used, and also some other modeling systems for water modeling. Yes.
Thank you. Do you have more questions on your list there, Nikki? I don't have any more.
Yes, from Kate Jensen. EGCS supplier, will you take into account the actual SOx emissions from EGCS within 100 ppm fuel sulfur equivalent, and not the requirement in ECA 1000 ppm fuel sulfur equivalent?
Will you take into account the
actual SOx, the sulfur dioxide oxides emissions from EGCS?
Yeah, we would like to we try to take into account all the emissions from various sources of the ships. So also these gray water, black water, etc., and all the pollutants to the seas and to the atmosphere. So we try to be as comprehensive as we can in addressing the emissions and discharges.
A comment made by Jukka-Pekka regarding the business as usual. We will have the global sulfur cap. EDI developments will be included, as we will be the vessel fleet size development, weighing for compatibility with the IMO G8 G4 study. And also one question we have from Franklin Karkada. In considering the impact of the scrubber operation, have you considered the study done CDELF on the carbon emission impact? Is a comparison between using compliant fuel and using scrubber with high sulfur fuel. The study considers the well to take to wake energy.
Yeah. Okay, there were two questions, very long ones. But
well, actually,
yes,
the question is.
Yeah. Thank you, Nikki. The short reply to the first question is that yes, of course we will allow for the global sulfur cap, and we try to anticipate any other further reductions also, as far as that is possible. So we try to include all the limitations in emissions, also in port areas. There might be specific limitations, and we actually have a fairly extensive review going on about the various limitations of shipping emissions. It's actually pretty complex, but we are reviewing those and try to include all of those into it.
So Jaakko, I have maybe one last question, and then maybe we should move on. There's a question from Mats Björkendal, and he asked that, I mean, we complete the project at 2024, and is this too late, since many EU member states have intentions to impose restrictions on limitations on the use of open up scrubbers already now?
Yes, that's an excellent question, actually, and if I would be a pessimist, I would say that yes, that is too late. but of course, this was initiated by European Union, and they made this call maybe a little late in that respect. But I think it's still very useful, even though this would have been even more useful a few years ago. But if we had started a few years ago, you are right. Yes.
Okay, thank you very much, Jaakko. We should move on in the program. If we could applaud you, we would do that now. So our next speaker is Valerie Chatterley. We're very happy to have you here. It's either very late or very early for you because you're in the US. So we're glad that you stayed up so late to talk to us. And Valerie is a consultant to the Carnival Corporation's exhaust gas cleaning system program since 2014. And Carnival is, you will probably tell us about that, the cruise ship company that has many scrubbers installed. And Valerie is an experienced chemist, environmental consultant, advising organizations how to meet stringent US and international environmental compliance standards. And you work both in the private sector as consultant and with the public sector on regulatory agencies. And you will give us a presentation here today that's called Exhaust Gas Cleaning Systems and Environmental and Operational Experience from an Operator's Perspective. So please, Valerie.
Pleasure. Thank you so much for the opportunity to present today. Just going to check with you to make sure that you can see my screen.
Yes,
see the
we can.
presentation?
Yes.
Okay, thank you. Thank you. Yes, so as Eric said, my name is Valerie Chatterley. I've been involved with the Carnival Exhaust Gas Cleaning System program since really the very beginning, and I've helped them design and set up their sampling program for both wash water and for some of their exhaust emissions testing. So with that, we'll lead into the first slide. Carnival takes and fully supports the important implementation of the global sulfur emission, or global ECA. And we don't necessarily commit to there being only one good solution to the sulfur emissions and also to other emissions from shipping. Our primary solution for our existing fleet are exhaust gas cleaning systems. And then we also have other options such as LNG. We were one of the forerunners in putting LNG on ships, and I believe we're one of the have the most number of ships right now equipped to operate on LNG. And also we have, I believe, the most number of shore power capable ships, and we have certainly the most cold ironing capability within the cruise industry. And then our fourth compliance option is to do and use compliant fuel. And really we evaluate which the situation and which one of these options would be best suited. So currently, our primary solution are the EGCS or scrubbers, and we believe that they impart significant air quality benefits with no impact to the marine environment. We also agree, and I believe somebody mentioned or asked a question about a CE Delft study. I'm not sure if it was the recent one on CO2 emissions evaluating refining versus scrubber operation and low sulfur fuel and the CO2 footprint. But we do believe that the EGCS are certainly a suitable transition technology moving towards a carbon neutral future. In addition to these four areas, we are also committing significant resources to evaluate future alternative fuels and next step technologies, including bio-LNG and fuel cells with our partner EcoSpray Technologies. This is just a little overview of how our program started and our operational experiences. Our very first installed scrubber on a ship was back in 2006. Based upon that experience, we spent 8 years developing and refining our system. 2014 was our first installation. And in between 2014 and today's current date, we have 6 years of air and water testing on board the ships. I believe we have the most extensive testing program, certainly in the cruise industry. Currently to date, we have 644 wash water sampling events and unique samples on 83 ships. And we've also done 10 emission tests on 10 ships. And as far as our operational experience, I'd like to make a key point that throughout this time, we've had a high level of reliability or availability, as we call it. Availability meaning anytime we'd want to use the system, it's available 99% of the time. The 1% that it's not available, generally is because the engine that it's attached to is undergoing some kind of routine maintenance. There are maintenance requirements. So that's really where our availability drops below 100%. And then our total usage rate, which is the amount of time that we use the scrubber when it is an option within an ECA. We typically, our goal is to operate them 90% of the time that we can. This year has been a little bit unusual, so we've dropped below our performance target, basically due to very unique circumstances with COVID for this year. And as far as the this year, currently we have 77 ships with 250 certified systems installed and operating. We, like I said, have an extensive wash water sampling program, and I believe we have the largest wash water set of data in the marine industry. And I said earlier, 644 sample sets, 83 ships. We really spent a long time establishing protocols and standards for our sampling program. Our crew receives extensive training on the appropriate way to take samples and the expectations. We have a sampling manual that provides detailed instructions. We have videos. We have a training center in Holland where the crew are actually trained in how to take these samples in addition. Of these 644 sample sets, each one contains 3 samples, one located at the seawater inlet, one taken immediately after the scrubber tower, post EGCS, and then one at the overboard discharge point. And back in 2019, we requested and gave DNVGL our laboratory results from the initial 281 wash water samples from 53 ships. They took those laboratory results, evaluated the results, and then compared them. Primarily, the exercise was to compare them to what the IMO requirements were, the standards that actually applied to EGCS. And really, we found that our, for example, PAH, and especially as the phenanthrene equivalent, was significantly below what the IMO criteria or limit for EGCS wash water, and also for nitrates. And this is, of course, wash water sampling. In addition to this, we are continuously monitoring the required parameters. So beyond that, DNVGL decided to compare it to other industrial wastewater discharge criteria. And we chose the German wastewater ordinance primarily because they had the most number of parameters that aligned with what you would find in potentially in EGCS wash water. And as you can see, and it is very difficult to see, but you know, really the only 2 bars that are showing are nickel and vanadium, which would be expected because those are constituents and found in HFO. We occasionally do find in our samples arsenic, lead, mercury, and what we also found was that anytime we were seeing those after the scrubber tower or at the point of discharge, they were also coming in with the seawater inlet water as a you know, as a background concentration already existing. And it got to the point when I was reviewing some of these laboratory reports that I could almost identify which region the ships were operating in based upon the incoming seawater metals content. And then finally, and even though it's really an apples to oranges comparison, DNVGL chose to look at the EU surface water criteria for their EQS. And of course, these are not meant to apply to point source discharge limit, which is what would apply to an EGCS discharge. However, they are very stringent criteria. And as you can see, even with this extremely stringent criteria that's meant to apply to an entire water body quality, we were still below these EQS in all of these parameters. And in addition to our own DNVGL work, which was sort of a starting point, some other studies have carried on and taken some additional data and were sponsored. I believe this one from CE Delft was sponsored by CLIA and Interferry. And this utilized the MAMPEC model and based the discharge and the modeling upon a reference scenario, which I believe was ships operating in a harbor, burning the equivalent or consuming the equivalent of 40 tons of fuel per day, 365 days a year. And they equated the amount in the discharge water with the amount of fuel consumed. They were able to do this through flow rates, et cetera. They utilized the MAMPEC model, which is an IMO recognized model for other regulatory purposes, such as ballast water and antifoulants, and input those reference scenarios, and essentially found that the accumulated concentrations at equilibrium within the water were very far below, not even 0.1% of the Water Framework Directive environmental quality standards. They also evaluated the port sediment potential for accumulation within port sediment, and also found that the potential for accumulation was extremely low. And then I don't know how, if anyone in the audience or on the panel was at MEPC, I believe it was 74, when Japan presented their MLIT study, which is a pretty comprehensive modeling study and also whole effluent toxicity testing. And they basically evaluated the predicted environmental concentrations from tests that they did, I believe on a test bed type scrubber, and then evaluated against the MAMPEC model and also predicted environmental concentrations. And basically they found that even in a worst case scenario, 10-year concentration increase in key areas surrounding Japan totaled to less than the current concentration by a factor of 100. So they feel it's not going to cause any short-term or long-term effect on water quality. And then they put in these, the part of the thing that was so nice about the presentation that they did, it was quite humorous, was everything was done in these cartoons that you see off to the right, was sort of how they summarized their research. This is the first time I've seen that, so it was much appreciated. Air emissions studies, ongoing studies and results. Here you can see just a summary of a few of our results on the bottom left-hand corner, along with some reductions that we've observed. I think primarily, and at the very far right, you'll see the reduction in SOx is approaching greater than 98%. I don't think there's any question that EGCS are extremely effective at the purpose that they were designed for, which was to remove SOx from the air emissions. And we have very good success with that. We're also finding a small reduction in NOx across the EGCS, and CO and also elemental carbon, organic carbon reductions in the range of 20 to 60%. We're seeing reliably some pretty significant PAH reductions of 40 to 60%. And then with the particulate matter, we have had some variable results. And I think that these numbers agree with the literature. The literature ranges, I think I've seen numbers as high as 90% reduction for particulate matter. And then I've seen some results that are significantly lower than that also. And I think with the particulate matter testing, it's heavily influenced by the testing method and the sampling setup. And it's an extremely complex, as I'm sure many of the participants on the panel have experienced themselves. As far as our testing methodology, we've used ISO 8178. And we're currently in discussions with the US EPA to do a side-by-side comparison between an alternative method, US EPA 5. One of the confounding factors with the particulate matter testing after a scrubber are temperature and moisture heavily influence the sampling system. And just as a reference, you can see at the bottom just some photograph of some filters from one of our tests before the EGCS, immediately after the engine, and then the exhaust, post EGCS with the EGCS turned on. As you can see, we have quite a number of reputable partners that we've worked with on our testing program. So, in summary, we've taken a multi-solution approach to support the implementation of the global ECAs, including EGCS, LNG, shore power, and the use of compliant fuels. We have over 15 years of experience and millions of operating hours And so our AGCS have a proven and demonstrated track record of reliability and performance. We established our extensive air and water sampling program. We wanted to acquire as much information and factual basis to support objective science-based regulatory decisions, and also to inform our own decisions internally. We feel that the AGCS have a positive air impact on air emissions, which of course have benefits to human health and no impact to water quality or the marine environment. And the test methods for the exhaust emissions, you know, the methodology certainly accounts for the variability in our results. And I think that's an area going forward that needs to be further refined in order to get some consistency with some of the measurement campaigns between either various tests or methods. So we have you know, obviously this year is a bit unique. Prior to this, we had a whole long list of things we wanted to do for future investigations, but currently this is what we are able to do in the near future. We've been in contact with the University of Southampton in conjunction with Lloyd's Register to do an evaluation of any acidification potential from EGCS wash water discharge. And as I mentioned prior to this, we've been in talks with the US EPA, they're experts there, and using an alternative method, which is EPA method 5, which is, as far as I know, the only method in conjunction with 202 that is designed or approved for use in a post-EGCS environment. So if there's any questions that I can answer, I'd be more than happy to open it to questions.
Thank you very much, Valerie, for a nice overview. We have a few questions. The first one I can take two together. There is a question from Octavio again and Mikko Heikkilä about what is your fraction of closed to open loop scrubbers, and also what is your future plans for investing in scrubbers? Will you use more scrubbers in the future?
Yeah, so our systems are all from one manufacturer, that's EcoSpray. They are a partner, and we tended to use just one company, and all of our systems are open loop exclusively. Okay. And part of that decision was based on the environmental review that we did, and also the added complexities that we're needing to use chemicals, for example, with a closed loop system, the complexity and other factors that come into play with that.
Okay.
And as far as future installations, yes, and I had the number written down here. I just looked into this today, but we do have plans to install these on several more of our ships and continue on with our installations. Obviously, right now things are, you know, our planning is a little bit off because of COVID, needless to say. So, but yes, we're still planning on utilizing these systems as just one component of our environmental programs.
Thank you.
Just to let you know that the poll is open and we are waiting for your submissions at the same time. You have around 8 minutes.
Okay. There's also a question of these studies you mentioned on measuring air emissions, if you're going to publish those or make them available. That's the question from Octavio Marin.
Oh, no, that is a good question. And then that's something that probably we will need to review. We've just completed actually one of our final tests and are still getting some of the results back. And I think we would like to complete this at least next series of tests with some guidance from the US EPA. And then, yeah, I think it would be great information to share. Absolutely.
Okay. And then we have a question from Ian Williams. He asked how temperature and moisture impact sampling for wastewater and how it impacts the concentration values. I'm not exactly sure what it means, but maybe you do.
Did you mean exhaust emissions, maybe temperature and moisture, or?
It says sampling for wastewater, but yeah. Well, we can skip that if we don't understand it.
Yeah, sorry, I don't understand the question.
Okay. There's also a question, there's a fund being suggested for R&D work to develop alternative fuels. And do you expect to work with that or in the future?
I would say that in general, I can't answer that question specifically. I think in general that we are always open to collaboration and furthering knowledge and cooperating in any way that we can to obviously increase the knowledge. I think right now it's challenging times in general for the cruise industry with the uncertainties surrounding COVID and operations. But I do know that in the corporation itself has a willingness to participate in furthering knowledge, absolutely, in research.
Okay, thank you. And then we have a question from Jukka-Pekka Jalkanen. He says, I read it, it is often quoted that the discharges are compliant to IMO washwater criteria. What if the question becomes, are the regulations including all biological or relevant compounds in water phase? Do you think, so basically it is, I mean, I know there is a development of these washwater criteria has been for many years. Do you think they include the relevant compounds?
I do. I think, and if you're talking about the continuous monitoring requirements, they are certainly indicators of the water quality. And I think that those continuous monitoring requirements then are confirmed and by the annual sampling that's being done. And I think when you're looking at monitoring wash water, et cetera, on a ship environment or really anywhere, you're constrained by the equipment and the technology. And I think under the situation, the parameters that are being evaluated are absolutely applicable to what you would find in a wash water from scrubbing exhaust gases. So yes.
Okay. And then we have a question from Leonidas Entsiakristos in Greece. And he wonders first if you can reach both 0.5S and 0.1S levels. And I know you already said you can, but then he has a follow-up question. So you're using scrubbers in ports or also for auxiliary engines?
Yes. And actually the question about the 0.5 and 0.1 is a good question. When we are operating our AGCS, we reduce our sulfur, our SOx levels to that which is below what the actual limit is. We always give ourselves a margin. So if the requirement is 0.1, we're typically at 0.04 for our SOx emissions. So if that answers your question, yeah. Yes, we can comply, and it's a matter of adjusting the amount of wash water, et cetera, into the scrubber tower. So very, I don't want to say easily done, but yeah.
But you also use them when the ships are in port?
Yes, and we try to utilize it. We can, absolutely.
Oh, okay. And there's another question. Did you say, I missed that they operate for 80-90% of the time? This is from Jens Borkin Kleefeld. Should not be operated all the time if you want to meet the sulfur requirements.
So, well, yeah, that's a very good comment, and I should probably clarify that. We are always in compliance. If we're not using our AGCS systems, then we are using compliant fuel. So, and it just so happens that this year, typically our usage rates are much higher. This year has been unusual in the fact that our ships have been moving a lot of times on short notice, unplanned, and so fuel availability, et cetera, it has been, there's been challenges with our usage. But yeah, no, we are, we'd love to use our AGCS 100% of the time. Sometimes there's constraints, whether it could very well be a local restriction. So we can't use the scrubber then, and we have to switch to a fuel or whatever the local requirements are. So,
okay.
Yeah.
Okay, thank you very much, Valerie. I think we ran out of time. Good to have you here. And with that, I will leave the word back to Jaakko, who will share the rest of this session.
Thank you, Erik. So our next speaker is Liudmila Osipova, and she's a marine researcher in the International Council on Clean Transportation. And the ICCT is an independent environmental non-profit organization with a head office in Washington, but they also have a regional office in Berlin in Europe. So Liudmila, please.
Thank you. Let me share my screen. Can you see my screen?
Yes, that's fine.
Yes.
Okay. So good morning, everyone. Thank you for the nice introduction. My name is Liudmila. I am today presenting the results of our soon-to-be published report on the global scrubber wash water discharge assessment under the new IMO regulations. As many of you are aware, this new IMO sulfur cap restricts maximum allowable sulfur content of fuel to 0.5%. This criteria can be met by using an alternative low sulfur fuels or a compliance technology or scrubbers. And because scrubbers is a more affordable alternative than cleaner fuel, more than 4,000 of them were installed by 2020. You can see it in this plot. This is 4 times higher intake than the previous 2019 year, so 2018. So if you look at this graph, you will see that 10 years ago, only 6 ships were fitted with scrubbers, and now it's more than 4,000. So probably this information is all familiar for you, but just a quick overview. What is the scrubber? It's technology that can be used along with heavy fuel oil and still meet 2020 sulfur cap requirement. Basically, it removes a portion of the sulfur from exhaust gas before emitting it. And scrubber can be of different types, open loop, closed loops, or hybrids between those two. Depending how they eliminate sulfurs. An open loop scrubber, you see it on the right side, it uses large volumes of seawater for the processing. And the closed loop scrubbers in the left uses specific alkaline water solution. Both processes are not completely emission free. You can see that both of them can release sludge and wash water. The wash water can be treated, but this is an optional, and often it's not actually the case. For example, one of the major scrubber manufacturers like Alfa Laval have reported to the European Commission that they open loop scrubbers do not specifically treat wash water in any way. The ICCT recently published a report providing the detailed information on wash water content. And the data shows that scrubber wash water is commonly more acidic than the surrounding seawater, and it's also higher in temperature. It can contain polycyclic aromatic hydrocarbons, nitrates, sulfates, and heavy metals. And some of the elements were shown to be accumulated over time, and they can cause various toxic effects. But so far, we're not aware what wash water volumes will be emitted globally by the current marine fleet. And also, where is this pollution hotspot going to happen? In what territorial waters or marine protected areas, and are they going to be affected or not? So to answer those questions, we modeled the scrubber wash water discharge distribution around the world. We map and rank scrubbers discharges by ship type, flag state, national water, and major port. And we believe that this information maybe can be useful for some national authorities or stakeholders just to be aware of what is happening and where. For that, we combine several comprehensive data sets, and I will give you that very general overview of what have been done for making this model. All the detailed information is available on the ICCT website, and you see the link belong to this report. So firstly, we use Clarkson World Fleet Registration dataset, and we identify the ships that installed scrubbers by the end of 2020. And then after that, using the ship individual numbers, we match them with AIS dataset provided by the Exact Earth. We model power demand of these ships using our previously developed SAFE model, or systematic assessment of vessel emission model. This model allows to calculate power demand per hour for each ship in the data set. So knowing the ship energy demands, we were able to estimate scrubber wash water discharges using the formula presented here. For the wash water flow rate, we used IMO recommended values. It's 45 ton per megawatt hour for open loop scrubber and 0.1 for closed loop mode. This value were recommended by IMO, but actually many studies shows that they are higher. But we decided to do more conservative estimates because it's not fully known what is actual wash water rates in which state. So now it's important to mention that results model so-called pre-pandemic ship traffic pattern. We used 2019 ship traffic as a pre-pandemic baseline scenario of ship activities. And then we estimated the mass of wash water discharges by the ships that had fitted scrubber by the end of 2020 to have an idea of what is going to happen in the future. So moving on to the results. Of the approximately 82,000 ships that we were able to identify in 2019 global fleet, we found out that 3,628 ships were fitted with scrubbers. This number is lower than the number reported by DNVGL, but since then Clarksons had added additional ships with scrubbers to the data set. Of all reported scrubbers, 85% were open loop type, 14% were hybrids, and only 1% were closed loop. Bulk carrier, container ships, and oil tankers responsible for 3/3 of all scrubber installations and 70% of scrubber wash water discharges. On the other hand, chemical tankers and cruises, despite the small absolute number of installation, they have highest proportion of fleet fitted with scrubbers. For example, in this plot, you can see that bulk carrier have the highest absolute number of installation, but only 8% of all bulk carriers carry scrubbers, while cruise ships have the lowest absolute number of installations, but almost 20% of all cruise ships right now use scrubbers. Overall, we estimated that it will be 10 billion tons of scrubber wash water discharge within a year globally. Just for the context, the actual global shipping sector carries about 11 billion tons of cargo each year. So the number of released wash water globally is almost the same as the number of cargo that's carried by the ship fleet. These estimates exclude 421 million tons of discharges that will not be emitted because of some national level regulations. 80% or 8 billion tons of wash water will be released within 200 nautical miles from the coastline. And in the map, you can see that worldwide discharges will form 3 prominent hotspots. One in the Caribbean Sea in the west, then Baltic Sea, North Sea, and Mediterranean Sea in Europe, and Strait of Malacca in the east. This is the top 5 countries with the largest wash water discharges in the national waters. As you can see, it's US, UK, Italy, Greece, and Japan. United States is number 1 on our ranking list. You can see that the discharge absolute volume is very high. But this is mainly because United States has one of the largest territorial sea area. Actually, the US discharge water per unit of area is relatively small. On the other hand, United Kingdom is just slightly below the United States, but the territory is 4 times smaller. And more than half of these discharges belongs to the UK overseas territories. For example, only Cayman Islands territorial sea will receive 44% of all wash water emitted in the UK. I also have to mention that even though Singapore is not in this list, but this is only due to the very small territorial sea area. However, Singapore holds the first place for the highest concentration of wash water. It's 15,000 tons per square kilometer. And this is despite the fact that Singapore actually already partly regulates scrubbers and banned wash water discharges in its port. Moving on to the port analysis. This map shows wastewater discharges in ports. You see there's hotspots over there, very similar to what we've seen to the previous slide, yeah? But with two exceptions. There are large discharges in Canada and Australia. In the map, you can see names of 10 ports that have the highest wastewater discharge. Among them are ports of Vancouver and Port of Sydney. Overall, of top 10 ports, all the top 10 ports will receive 83 million tons of freshwater. A half of wastewater will be dumped in only one port, Port of Georgetown and Cayman Islands. The Cayman Islands that I already mentioned in the previous slide. This is due to heavy cruise ship traffic. Out of 50 scrubber-equipped ships we identified in the Port of Georgetown, 49 were actually cruise ships. And there is a reason behind it. You see the plot here shows a mean power consumption by the ship type and also time that ship spends in the port. So you see that cruise ship spends 25% of the time in ports and have the highest import energy consumptions. Average power consumptions for the cruise ship in port is 12 megawatt per hour. Compare it to the next one, to the oil tanker, which consume on average 3 times less and spend only 2% of time in port. Overall, cruise ships were responsible for from 74% to 100% of all discharges in the top 10 most polluted ports. And finally, we also attempt to estimate how much wastewater will be discharged in 15 particularly sensitive sea areas, or PSSIs. These areas have special shipping navigation status designated by the IMO. They usually include threatened reef, coral reef systems, and endangered marine lives, and have a special protection status. We found out that 665 million tons of wastewater will be emitted within PSSAs, and 90% of this water will belong to Western European waters, Baltic and Baltic Sea PSSAs. We found relatively small emission in Caribbean PSSAs. They have 3 PSSAs, but this is mainly due to very small area of those PSSAs. They only 1% of all PSSAs in the world. And literally the resolution of our data were not able to capture how much wastewater going to be discharged in these small areas. But as you can see in the left inlet, that the concentrations are quite high in this area. And finally, 32 million tons will be released in the Great Barrier Reef in Australia. And this seems to be mainly driven by the 3 coal exporting ports shown in the map. So in conclusion, based on the presented analysis, we formulated a few policy recommendations that we think can be reasonable. We believe that issue can be addressed at a different level. The IMO could ban or control wastewater discharges, at least in particularly sensitive sea areas and nearshore waters. But also individual states can proactively control wastewater discharges in their national waters. And it's already actually done by some states. And also they can think about installing on-land facilities for sludge disposal. Nearby countries could work together on harmonizing scrubber discharge bans. Like, for example, Malaysia, Indonesia, and Singapore have already prohibited open loop scrubber discharges in the port. But this does not extend into the entire Strait of Malacca, which passes through each country's territorial seas. And Strait of Malacca will expect to receive the largest concentration of wastewater discharges in the world. And finally, also at the port level, scrubber discharges can be controlled. They can enforce of using onshore power in ports, especially those ports that have cruise ships. And finally, water and sediment pollutants monitoring could be useful for controlling the concentrations that can accumulate over time. So thank you for your attention. If you have any questions, please ask. And this report that I just presented will be published this month, at the end of this month. And it will have also a free access interactive map. It will include all detailed information on wastewater discharges around the world, and anyone could freely access it and just to see what is happening in their own national waters for ports. And thank you for your attention.
Okay, thank you, Mila. There's already a question. Sorry, can you hear me?
No,
All
sorry,
right.
I think I have some problems. Okay, now I hear. Hello?
Yes, we can hear you. Yeah, right. So there's one question from Mikko Heikkilä. Just yes.
Meanwhile, you can submit your questions to the polls.
Yeah, right. So Mikko Heikkilä is asking, is high power consumption of ships at Georgetown due to the fact that some of these are in dynamic position mode?
Could you repeat it, please? Because I have only, I'm losing sometimes the connection.
Oh, sorry. He's asking about the high power consumption of ships at Georgetown. Is that due to dynamic position mode?
The high power consumption in the Georgetown is due to heavy cruise shipping traffic around this area. Because the way how we estimated the values, we put the 1 nautical mile buffer around the port and see how many ships are entering this area and stay there and consume, and how much energy they consume. And then based on this energy consumption, we estimated the discharges. And in Cayman Island, particularly, the cruise traffic is really high. And as you saw on the graph, there was the power consumption in ports is very high for this ship type. And that's why the value is so high.
Right, good. Then there's a question, Juan Liu. A lot of data, there's a lot of data. Is there any validation? So how did you validate the predictions?
Yeah, that's actually there is, it's not really a prediction, it's more like a real data set. The only thing that we modeled, actually, it's the power consumption and how shipping movements affected by the weather conditions. So all these parameters were taken into account, and we did some sensitivity analysis. All this information, like detailed information on the model itself, you can freely access it on the ICCT website. And if you need a link, I can provide the link.
Okay, thank you. I have one question myself, actually. We are going to produce similar distributions of wastewater with a steam model. So I'm interested in comparisons, intercomparisons or predictions.
We actually did very brief comparisons by looking at your results, and just to see if the values are comparable, and they were really comparable. So yeah, please feel free if you need some numbers, we can share.
Okay. I'm glad to hear they are comparable.
Yes.
Good. Nikki, can you see any other questions?
Yes, so Regina Sariotis just asked, to which extent is onshore power supply used in the ports in areas like the Cayman Islands?
Yes, that's a very, very good question. We tried to find this information, but unfortunately, it's not currently publicly available. So we couldn't actually account for the shore power usage. So that's unfortunately was not included in the model, but that's something that can be definitely improved.
Also, Jukka-Pekka Jalkanen asked, how do you account for weather impacts? This was done in a very simple way in IMO GHG4 study.
Yeah, that's how how we did that. That's how it's in IMO GHG4 study.
There's one more question from Mikko Heikkilä. In the model, how much time closed and hybrid were run in closed mode?
We assumed, sorry, yeah.
Yeah, sorry, please go ahead.
We assume that all hybrids will operate in open loop mode, because the assumptions behind it was because when you install a scrubber, like even if it's a hybrid scrubber, you know that the closed loop scrubbers actually requires extra steps for using them. And you need some special water solution there. You need to accumulate the sludge produced by them. So we just assume if the ship had a capacity of using it in open loop mode, it will use it in open loop mode.
Okay.
Also, Kate Jensen asked, what is your evidence that EGCS waste sludge is not delivered safely ashore as per the requirements?
We did not look at the sludge at all. We only look at the wash water. It's it's a two different type of contaminants when you use scrubbers. And sludge is supposed to be carried and disposed, but it doesn't mean that the wash water is not polluted all over the way.
There's one question from Regina Asariotis. To which extent is onshore power supply used in the ports?
We
already addressed this question.
Yeah.
Sorry.
Okay.
Right. So, Nikki, can you see any other new questions?
From Christian Bachels, the energy consumption showed in the slides, 12
Yes.
MW for cruise ships, for example. They are for the vessel at rest or in a port?
In the port. And it's just the average estimate, right? So it's not necessarily provides what one particular ship consume. It was average over ships.
Okay, thank you, Liudmila. We will go to the next presentation. The next one will be kept by Associate Professor Erik Ytreberg. He's working at Chalmers University of Technology, and his research has focused especially on assessing the environmental impacts of shipping. So, Erik, please.
You're muted, Erik.
Sorry, rookie mistake. Okay, good. Thanks. Thanks a lot. Okay, so I will give a presentation about potential impacts of scrubber discharges on the marine environment. And this presentation will be based on results derived from two already ended projects. The first one is a project named SHIBA. It stands for Sustainable Shipping and Environment of the Baltic Sea region. So that was a European Union bonus project. And then it's a Swedish national project called Policy Instruments and Evaluation of Impacts from Shipping. And then finally, I will also bring up some data that we have produced so far within the eMERGE project, and also a little bit about what we are aiming at within the eMERGE project. So to start, I will go through three different methodologies or approaches on how to evaluate impacts or risks from scrubber discharges. The first one is called life cycle impact assessment, or LCIA. The second one is ecotoxicological studies, and the third one is site-specific environmental risk assessment. But before I go into these methodologies or approaches, just a little bit about some background. So we started to work with this quite extensively in this SHIBA project, and during this SHIBA project we did an extensive review to characterize different waste streams with respect to nutrient and chemicals. And on this figure you see here a bunch of different waste streams that could contain various chemicals that are being discharged to the marine environment. So we have that very large database now, and we are also using this database within the eMERGE project, and we have also updated it with recent publications. And we have primarily focused on the scrubber discharge water. So now within eMERGE we have data on 87 open loop discharge water and 23 closed loop discharge water. And this database then comprises measurements of more than 90 contaminants and also nutrients and pH. So this kind of data is what we are using and what I have been using now what we have been using now in different assessments. So here is a deliverable which was written by me and Anna Lund Hermansson and Ida-Maja Hasselöv at Chalmers last year within eMERGE. And here you see the average concentration of the 16 US EPA pHs in open and closed loop discharge water. And the arrow bar here then represents the 95% confidence interval. So in general, the highest concentration is here observed in the closed loop discharge water, which is also as expected. And to the right here you see the metals, and also here we have significantly higher concentration in closed loop discharge water as compared to open loop. And what has also been shown in previous presentation, we have an IMO discharge criteria, which is set as 50 microgram per liter of pH phenanthrogen equivalence. I'm not really sure where that discharge criteria actually comes from. I have not seen any risk assessment and so on to see that this is actually safe for the marine environment, etc. But then we have no criteria for metals. So what can you do with this kind of data? Now you see two graphs here where we have various concentration of a bunch of different metals. Some of them are more toxic than others. Then it's a little bit tricky when you get the question, what will be the adverse effect here if we discharge open or closed loop water to the marine environment, and which one is most toxic, etc. So one way to handle this is to use this life cycle impact assessment. And in this case, you use something called characterization and characterization factors, meaning that you relate your compound that you're interested in, for example, pH or metal, to a reference substance, which is a substance called 1.4 dichlorobenzene or 1.4 DCB. So you relate your toxicity to that equivalence. And it's a similar approach as you use for global warming potential, where you use carbon dioxide as a reference substance. So we use this from characterization factors from a large scientific program called RECIPE. And we basically then multiply the characterization factors with the average concentration of the different pHs and metals. And this is what you then can produce. So here you see the average toxicity potential per cubic meter of water in closed loop and open loop. So yeah, as you see, there are the toxicity potential is significantly higher in closed loop discharge water as compared to open loop. So this is a way of how you actually can compare apples and oranges, even though that these characterization factors, they are generic for the marine environment. So there are some, of course, some high uncertainties in this, but it's one way to actually do a comparison where you are comparing very complex waters that contain a lot of different chemicals. But perhaps toxicity potential per cubic meter is not the best unit. So a better unit is then to also take into consideration the discharge rate. We previously saw discharge rates from IMO, I think, which is 45 cubic meter per megawatt hour for open loop. What we have been doing in Emerge is to compile data from various ships, and we see that the average discharge rate is almost two times higher for open loop, and it's also higher for closed loop. So in this figure, you see the toxicity potential per megawatt hour. So we basically multiplied the concentration per cubic meter, which you saw on the last slide, with the discharge rate. So here we see that the bars flips basically. So now you see that the toxicity potential is significantly higher in open loop for open loop scrubbers compared to closed loop, if you express it as toxicity potential per megawatt hour. So what does this then tell you? Well, it tells you a little bit about the comparison between open and closed loop operation, but perhaps one is also interesting to compare the toxicity potential from scrubber discharges as compared to the other waste streams, as you see here on this figure. So what we did, or one thing that we did, is that we used a case study with a typical RUPAX vessel operating between Sweden and Finland. So here you see the results when we assume that this vessel is operating with an open loop scrubber. You also see the toxicity potential for grey water, black water example. And these are then a function, the volumes are then a function of the number of passengers. And then we also use this big database that I talked about in the beginning of this presentation, where we have summarized various contaminants present in grey water and black water, and then multiply that with this characterization factor to get this combined total toxicity potential from the different waste streams. So we see that the open loop scrubber discharges is actually having the highest toxicity potential, and even higher as compared to anti-fouling paints. If we instead assume that this vessel is operating in closed loop mode, we see that the toxicity potential is reduced quite a lot, and now it's almost in the same numbers as the anti-fouling paints. So this is one way of how you can assess impacts when you're using life cycle impact assessment. And another way to do it is to use ecotoxicological studies, and this is something that we have been carried out in previous project at Chalmers, and this is also what will be done by various teams within the Emerge. And ecotoxicological studies, they are used on a regulatory basis primarily to derive threshold values of a chemical in various compartments. And now we are talking about the marine environment in particular. So these threshold values, they are also known as predicted no effect concentration, or PNEC value or PNEC value. And they are typically defined as the concentration of a given chemical substance that is not expected to produce adverse effects on the marine ecosystems at any exposure time. So you use ecotoxicity tests to derive PNEC values for single chemicals. That is usually what you're doing within REACH and other European regulations, but you can also use it for whole effluent toxicity tests. And with that, I mean effluent wastewater discharges. And in our case, that applies then to scrubber discharge water. This is how these kind of tests can be performed. You take your chemical, you add it into a test vial in different increase in concentration. You add your test species. This is one of the creatures, this crustacean Daphnia magna, which is very often used. And then someone like me or someone else is then after 2 days or 3 days is then looking how many of these creatures are dead or alive. And then you can plot your response, so the percent mortality towards concentration, and then you can end up with something like this. And if you have a second chemical, which is then the blue one here, then you see what is then the concentration needed to give a 50% mortality. This is what is primarily used when you're doing this lethal experiment. So if you only have this kind of data, what shall you do with it then if you are interested in one specific chemical, or if it's a scrubber water? Because we are not really, in a regulatory context, we're not really interested in knowing when will we receive 50% mortality of a crustacean. So what we are interested in is actually to protect the entire marine food web. And to the right, you see a simplified food web for the Northwest Atlantic. And I can imagine that you have some kind of crustaceans here in the middle of this food web. And it is very hard then to understand what kind of impact will this have for example, a tuna or a cod living in these areas. So to be able to answer that question on a regulatory context, we are using something called assessment factors. So if we only had this data from this crustacean and short-term tests, then you need to apply an assessment factor of 1000 to derive this predicted no effect concentration. So you basically you divide your toxicity response data with a factor 1000. But if you have more data, and this is why it is important that you have a lot of data, because then you will reduce the uncertainty and this assessment factor. So if you have data or more long-term toxicity tests, meaning that you're looking at more chronic endpoints, for example, reproduction and so on. And if you have three species representing different trophic levels, then you can reduce your assessment factor to 10. So if we just have a short look at the eMERGE ecotoxicity test battery, these are some of the species that we will investigate within eMERGE. So we have a bacteria, we have phytoplankton community, we have a macroalgae, we have a bunch of different mussels and oysters, and also a couple of crustaceans. So that means that we will fulfill the requirements to reduce the assessment factor to 10, since we have more than 3 long-term toxicity tests with species representing different living and feeding conditions. So the output in this case will then be the whole effluent toxicity predicted no effect concentration. So the unit here will be then percent discharge water that the environment can cope with. So this is what we'll be conducting, what we will be conducting during the progress of eMERGE. Okay, so going to the third methodology, this is environmental risk assessment of various compounds present in scrubber discharge water, and here you use two different parts in this environmental risk assessment. The first part is an exposure assessment, meaning that you do various modeling exercises, and this is also what Jaakko showed in the first presentation, that we will do a lot of modeling to dispersive modeling to see where will these compounds end up. So what will be the predicted environmental concentration in water and in sediment? These are the main compartments that we are interested in. And in the second phase, you do this effect assessment. And here is where these ecotoxicity tests come in, so you can produce this PNEC value. And with respect to most of the pHs and metals present in the scrubber discharge water, we already have PNEC values in place within the European Union. So we will use these PNEC values in eMERGE as well. So this is not something that we will develop on a compound specific level. So the last stage in this environmental risk assessment is that you do a risk characterization, meaning that you divide your PEC value with the PNEC value. And the magic threshold here is the number 1. So if you end up with a risk characterization higher than 1, you say that you have an unacceptable risk for the environment, meaning that you could end up with adverse effects. And if you are lower than 1, then you say that you have acceptable risk for the environment, so meaning that you have a low risk for adverse effects. So how will we do that? Well, when it comes to predicting environmental concentrations, this is at least what I think is very important, that you are modeling the concentration increase using various scenarios. So what will be the concentration increase, for instance, in harbors or in ship lanes due to the discharges of scrubber water? That is one part. And the second part is then to consider the site-specific background concentrations. And that will vary quite a lot in the European Union waters. And here is just an example of background concentration and the monitoring conducted under the European Union Water Framework Directive or the Marine Strategy Framework Directive. So you see here data from HELCOM and their HOLAS 2 assessment for pHs. So the southern part of the Baltic Sea, you see that we fail to reach good environmental status, meaning that the concentration of pHs in these sub-basins are exceeding this predicted no effect concentration or the environmental quality standard, while we see a different situation in the northern part of the Baltic Sea, in the Bothnian Bay, for instance, where we are achieving good status. So I think it is important that you need to consider the background concentrations when you're doing this kind of assessments. And here is another example where you see the status classification of Swedish coastal water bodies. Most of the water bodies here you see are gray. That means that they have not been classified for copper. But of the ones that have been classified, we see that 27% of them have copper concentration in either the surface water or in the sediment that exceeds this threshold values. In this case, it's labeled environmental quality standards, but it is the same as the predicted no effect concentration. But this is something that we will continue and work within the eMERGE, and it's an extensive job because we need to get hold of a lot of background data regarding environmental concentrations. So to conclude, I presented 3 different approaches on how to determine impacts or risks of various discharges, basically, but now I focused on the scrubbers. And we see that using this life cycle impact assessment approach and this RUPAX vessel, we show that the scrubber discharge water had the highest toxicity potential as compared to the other waste streams from that ship. And eMERGE will assess the whole effluent toxicity scrubber discharge water using different test species, as I showed you. And we will also try to derive this site-specific risk assessment of scrubber water, taking into account the background concentration in the different sea basins. And with that, I thank you for your attention, and I would be happy to try to answer any questions.
Thank you, Erik.
Thank you.
Very nice presentation on impacts of shipping on the sea. There's a question from Anne Christensen. Regarding scrubber emissions, would you expect that sufficient knowledge would be provided in the eMERGE project in order to be able to suggest regional handling according to IMO frame, for instance, in the HELCOM SPA regions?
Yes, thank you. That's a very good question, and we didn't touch upon that so much, but we have also, in eMERGE, we have identified and we will be using different case studies where we will do more extensive research, and these case studies are then selected to represent the wider sea area. So the idea here is then to also identify if we have particular sensitive sea areas where maybe one suggestion comes from eMERGE, and in others maybe we have another suggestion. So yes, that will be considered.
Right. Then there's a question from Brigitte Behrens. How would you deal with the chemical cocktail and combined toxicity?
Yeah, thank you. That's a very good question. That will be, of course, particularly dealt with in the ecotoxicological tests, because this is where we will investigate the impacts of the whole effluent, basically, because otherwise we will also do a lot of chemical analysis, but of course we will only be able to quantify what we are looking for, basically. So if we are missing something, that will not be seen in the chemical analysis, but it will be showed up at least in the response in the ecotoxicological tests.
Mm-hmm. Right. Thank you. Nikki, can you see any other questions?
No, I haven't received any more questions.
Yeah, it seems that there are no more questions. Okay, thank you, Erik.
Thank you. Very
nice. And now we will have time for some general discussion. So would you like to make some comments for the general discussion about any or all of these presentations? Are there any comments? If there are no comments at the moment, I would like to ask from Valerie especially on how would you like to develop this collaboration with eMERGE? What are your ideas about that?
I'm sorry, could you repeat? I didn't catch the first part.
Sorry. I was trying to ask what are your views on the collaboration of your company and eMERGE? What kind of ideas and what do you think as feasible forms of collaboration?
I think, and I can relay this on behalf of Carnival, that we're always interested in collaborating and cooperating and expanding the knowledge base in any way possible, and of course trying to do the most environmentally responsible options and investigating those. So I think we're quite willing to cooperate and would be willing, of course, to evaluate any requests or help in any way that we can. It's a bit challenging this year, obviously, I think for everyone.
Yes, because of the COVID measures, it's
Yes.
and some of us are much more busy than usual due to the COVID.
Yes.
So it's challenging. Yes, I agree.
Yeah, but I think it's a great idea, and we're more than happy to open up a dialogue or entertain any requests that we're helping any way we can, for sure.
Okay, thank you.
I have a question.
Oh, sorry, Nikki, please go ahead.
I have a question from Valerie. This question is from Mikko Heikkilä. Can Valerie Chatterley answer what is the average power consumption of a cruise ship in port? Is it really 12 megawatt per hour?
Well, I'm not going to get myself in trouble and answer that without talking to someone who has a little bit more of engineering experience with our ships specifically. But I do know that there are power consumption needs that are associated with carrying guests on board our ships that are perhaps unique compared with other vessels. So, and that's information that I would be more than happy to get firm and solid numbers regarding. I'd hate to try to make a guess and be wrong on that, but good question.
Right.
Jaakko, I have a question also, if I may. This is
of course.
Yes,
Please go ahead.
it's for Valerie too. As you know, Valerie, of course, there's a lot of focus now in the IMO to reduce greenhouse gases, and there's a lot of new policy instruments being discussed and so on. Do you see that this will affect in short or medium term the investment in scrubbers or the use of scrubbers, these new policy instruments?
And you're speaking specifically to localized restrictions?
No, I was talking about the greenhouse gas policy instruments that are coming, the EXI and things like that. If this will have an impact at all on the use of scrubbers too, and the CII.
I don't. And that's probably a good question for me to relay back to our team who's working on those issues. It really hasn't been a topic of discussion up to this point that I've been involved in. But it was funny. Obviously, one of my colleagues is listening in on this call, and I'm not sure if this is clarified for import usage, but the average is around 7 megawatts per hour. This is the answer that I got from a colleague who's probably in much better position to answer that. So thank you. And he says, yes, that is for import use.
Okay, thank you.
Sure.
I have one question to Liudmila also. Similar. Can you hear me? I have a question to Liudmila. So how do you see the collaboration with eMERGE? What kind of ideas do you have?
We would be really happy to collaborate, actually. We were thinking about, so moving on from what have been done, we have few ideas what can be done. And one of the ideas is looking not only just on volumes, but also on the content and overall pollutant load in certain areas. Especially, we would be interested, especially to continue working on this particularly sensitive sea areas. Specifically, we were concerned about coral reefs because, as you all know, the wash water is acidic and higher in temperature, higher in turbidity, and this is very damaging to the coral reefs. And it has been shown that acidity actually increasing effect of climate change on coral bleaching. Mm-hmm. So, and currently it's not really regulated anywhere in the area where corals are. And yeah,
we have a common interest there. What's the chemical content of the scrubber waters and how to deal with that in more detail? Yes, we have the same issue. We also have international collaborators in the project in US, Russia, South Korea, etc. So not in Australia, however, not yet. But let's see whether we can collaborate on that one.
Another thing I would like to actually address, that not discussed that widely, but I think it's important also to talk about what's happening with the sludge. We really don't know what are the volume of the sludge produced, and is there really so according to the IMO regulations, the sludge should be collected and disposed safely, but where are those disposal stations and how exactly it's being processed and what is the sludge content? That's something that is really not discussed currently.
Right, okay.
I have 2 questions. I received 2 questions. So these questions are for you, Erik. The first one is from Magdalene Papatheodoulou. How do you account for the accumulation of the various chemicals through the food web in the toxicological analysis?
That's a good question. I'm not really sure if we will account for that in the ecotoxicological assessment. We will primarily do what would you say? I mean, it's going to be long-term tests, but still it's going to be like for a week and to look at various chronicle impacts. But I don't think we will look so much into the bioaccumulation of various compounds by the organism. But I think that will be mostly addressed via modeling. But I'm not up to speed exactly how that will be performed within the project.
Okay, thank you. And the second question is, did you identify certain pollutants responsible for most of the toxicity potential of scrubber discharges? Which fraction? For example, vanadium.
Yeah, vanadium was one of the key pollutants. So it was mainly it's metals actually that has the highest toxicity potential, or yeah, both in open and closed loop water. So vanadium, chromium, copper, zinc, I would say are the key players.
Yes, Nikki, would you like to ask these other questions as well? I can see there are some other.
Well, I received these 2 questions for Erik, and the attendees, of course, can raise their hand if they have any questions, and we will unmute them if they would like to make a direct question.
All right.
Okay. Well, I just received one question from Jukka-Pekka Jalkanen. Is there any interest towards specific scenarios from the stakeholder side?
I have a question for Erik in the meanwhile, if I may. And it's these ecotoxical tests you talk about. Can those be used to make new wash water criteria that could be generally applied to all the scrubber ships?
Yeah, I think so in theory. And as I showed you, I mean, it's you can use a bunch of different approaches or methods to determine impact and risks. And I think one thing that I also highlighted in my talk is that you need to consider the recipient. So basically where you will discharge the water. So, but I know IMO they usually want to have a standard applied globally, but that's a little bit problematic, I would say, especially since you have sea areas that are more sensitive than others, and also as Liudmila also mentioned here, when it comes to the Great Barrier Reef, etc., and the corals, that is potentially more sensitive towards these discharges than in the middle of the Pacific, for instance. But we will see what we will come up with, basically.
Yeah, I could continue this comment by Jukka-Pekka on scenarios. We will of course develop this information network further, and we can continue discussions within that network. So this workshop is just a kind of first step, nice first step, but we can continue discussions within the network in the future. So for instance, it would be valuable to have your views on the formulation of scenarios, as Jukka-Pekka mentioned.
I just received a question for Erik. So the toxicity of PAHs and metals have been discussed, but what about the effect of sulfuric acid and low pH?
Yeah, thank you. That's a good question, and I skipped that part in my talk because we didn't have that much time. So therefore, I focused only on impacts from various chemicals or contaminants. But using the ecotoxicity tests, then the idea is then that we should be able to couple both the impacts from chemicals and also from due to acidification and also due to eutrophication. So it is very, I would say, the response could be very individual, depending on the uptake of NOx, for instance, within the scrubber. If you get very high nitrate concentration, then you could see that could be the major impact, basically, that you see eutrophication impacts. And if it's very acidic, then that could be masking other impacts and so on. So that, I would say, is the positive and the good thing about using ecotoxicological tests, that you actually could investigate the combined effects. That is something that we are missing when we're doing, for instance, environmental risk assessment of one compounds at a time. So I think this is the strength with eMERGE, that we're using a bunch of different methodologies to determine impacts.
We also have a couple of questions in the Q&A. So I think this is a statement for Jaakko, asking the assistance of the stakeholders. We have a comment from Sophie Delaire that Euroshore, the Association of Port Reception Facilities, can assist in our effort because they do collect scrubber sludge in their facilities. We also have a comment earlier done by Regina Azariotis for a general discussion that the shipping industry and some governments have proposed the establishment of an R&D fund to focus on development of alternative fuels, among other technologies, for emission reduction, under of course, the supervision of the IMO. This is likely to be adopted soon, and do we expect us eMERGE to work under to draw on the outcomes or inform this work? Will we address this topic in our project, Jaakko?
Right. Yes, of course, this is an important topic also. We will do some work on alternative fuels, for instance, LNG in eMERGE. But our main focus is on scrubbers and abatement methods, but we will also do some work on alternative fuels, yes. Right. Now it's Northern European time, 11 Central European time. I think we will conduct this workshop. Oh, Erik, do you have something? Erik, something? Maybe
No.
okay, not maybe not. So thank you for all the speakers and all the participants for this workshop, and I think this has been very useful and fruitful workshop, and we will continue this collaboration within this information network and other forums. So thank you all, and we'll conclude the workshop. Thank you for.
Thank you.
Thank you.
We would like also to inform our attendees that the recorded session will be uploaded in our YouTube channel, so they can visit and or share the session with their colleagues who were not able to participate. Thank you.
Yeah, thanks, Angelos. Good point. All right, thank you. Bye-bye.
Thank you. Bye.